right, with this video, I'm going to show you how to calculate z-scores for a single score in a sample using SPSS. All right. The problem with, you can't do it easily. So you can get SPSS to calculate z-scores and all sorts of things like that. But SPSS uses estimated population standard deviation, right? So when SPSS is calculating it, it's using this formula, right? When we're going to be calculating it, we want the z-score for a single score in the sample, and we also need to calculate that sample standard deviation, because when we run to SPSS, we get the estimated population standard deviation. So let's have a look at that. Remember, our z-score we're going to be calculating is, for example, you're going to have to do this for extra credit. So your score minus the mean, right? One score minus the mean divided by the sample standard deviation. So let's go to SPSS. Now I just used this data set to calculate the sample standard deviation with SPSS, as we did in class by hand, right? So we have, if you'll notice, we have the scores. We're going to use these same examples and the deviation, right? And the deviations. So say we want to calculate our z-score, right? We have to calculate first the sample standard deviation, which we can do various ways. What I'm going to do this time is simply look over here. We already did it with the last time. We calculated it. But if we have the standard deviation, estimated population standard deviation, let's write that out. Okay, so this is going to be that's a lowercase sigma, right? This is the sum of squares, which is minus, oops, that's a minus x minus the mean of x squared, right? Over, the main thing we need here is n minus 1. So this is this value right here, okay? We see it right here. We can also work with the variance, okay? So let's work with the variance to solve. Okay, so we're going to solve for the sums of squares. What we did here is we just got the sums of squares, but we don't have to do all this work, okay? We can simply go, we're going to call SS. So variance equals sums of squares, which is that sigma, the sums of the squares of these square deviations, right? Over n minus 1. Okay, if we solve for this, we're going to solve for the sums of squares, right? We know the variance, 12.9 equals sums of squares over 9, right? Because n minus 1 is 9. Then we just have to do a little multiplication. 12.9 times 9 equals 116.1, which we already knew here, right? We're going to do it as if we had not done all this calculation. So sums of squares is 116.9, okay? Which is actually 0.1, sorry. 0.1, that's a 1, 0, which is this right here when we calculate the sum of the square deviations. But you don't need to do all that when you do your assignments for z-scores to calculate your own z-score. So now we can calculate the standard deviation, which is just 116.1 over 10, right? And I know I just did this with that previous video, but square root of 11.61, I'm going to calculate that. 3.407. So standard deviation, that's 3.407. We need that. That's the sample standard deviation. It's very different from the estimated population standard deviation because this is a really small sample. As samples get big, the standard deviation of the sample and the estimated population standard deviation are going to be much closer, right? So 3.407. I'm going to clear all this, but I'm going to write it up here so we can see it. 3.407. Okay. Now we can calculate the z-scores. So transform, compute variable. Let's reset this, and we're going to call this z-score. That's not how you spell score. Okay. So the z-score equals, oh, we also need the mean of x, huh? So let's go over here and look at this. Mean of x is 5.3. All right. X minus, we go, minus 5.3. That's the deviation. Actually, we already have the deviation, but we're going to do it. I'll show you both ways to show. You don't even have to calculate your deviation, right? Over, okay. And this is where we're going to have the sample standard deviation, which is 3.407. We're going to do this two ways. We're going to do this the direct without calculating deviations. We're going to do it the other way. Okay, so here's z-scores right here. Okay, there's a deviation, and here's the z-score. And to check our work, we're going to actually use the deviations, because remember, z equals x minus mean of x over sample standard deviation. Okay, so we'll calculate it the other one, make sure we did the proper thing. So transform, compute variable, z-score, we'll call it z-score 2. Get rid of this, just deviation divided by 3.407, 3.407. Okay. Are they the same? Yes, they're exactly the same. So you can do it all by computing variable without computing deviations, or you can calculate just your z-score. I ask you for your deviation from the score, and you won't know what everybody else is, but you can do it either way. All right. Authentic